you will have your integers. And then if you try to divide these values, these integers, you will have your rational numbers. And from your rational numbers, you will have your real numbers. So you can study your real analysis. And because you now have your real numbers, I'm sure most of you are familiar now with your complex numbers. So you can actually build up from a set of natural numbers. In fact, what do we have here? You can go to calculus, topology, and other mathematics subjects. So what else? Why do we need to study number theory? We have the following. This is actually a quotation from Kronecker, 1823 to 1891. He said, God made the integers, but all the rest is the work of man. I don't know if you're familiar that number theory is the queen of mathematics. Are you aware that it is the queen of mathematics at this point? Mga BS math man kayo. In fact, wala. So, karon, aware na mo. So, mathematics is the queen of sciences. Ang mathematics, ang queen ng sciences. Pero ang number theory is actually the queen of mathematics. So, that is a quotation from Carl Friedrich Gauss, no? 1777. Okay na. 1855. So, number theory, gamit siya ng mga techniques from algebra, analysis, geometry, and topology. In fact, pati sa logic, computer science. And because of number theory, there are some development in these fields. What else? Why do we still need to study number theory? Number theory has some great applications. RSA, public key cryptography. You are aware with cryptography sa inyong JEC 104 na. Number theory, you learn also how to read and write some proofs. Is everybody familiar with set theory already? Dapat ang set theory is actually a prerequisite, I think. Yes, Math 101. Everybody meron ng Math 101? Hello?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yeah, prerequisite kasi ang Math 101 is proving. Again, you will be able to learn how to read and write your proofs in number theory. And it is actually a rich source of conjectures. So although they are easy to state, they are sometimes difficult to prove. In fact, there are some problems in number theory that actually has to take several years before prove, although the conjectures are made. Proving it takes a long time. Okay. So what will be the topics for our Math 106? We're going to discuss your integers. So that's what we are going to do now. Your divisibility, prime numbers, congruences, number theoretic functions, solving congruences, Diophantine equation, integers as sums of 2, 3, or 4 squares, primitive roots, quadratic residues. So for topic 1, which is on integers, we have the following specific objective. First, dapat at the end of the topic, you are able to enumerate properties of integers, including the Peano axiom. Sometimes it's read as Peano axioms. Describe the well-ordering principle. Construct proofs using the principle of mathematical induction. This one, dapat master niyo yung principle of mathematical induction kasi sa JEC 104 meron na yan, no? Then we have what we call the algebraic operations with integers. How do we write down the set of integers? It is denoted by this, Z. It consists of all positive and negative integers, including 0. So you have your positive integers, negative integers, and 0. Because 0 is neither a positive nor a negative. So this is how you write down the set. And the set of all positive integers, sometimes kaning natural number man god dapat appeal ang zero, no? So in other texts, they do not include zero. But in our case, we're going to include zero and we're going to denote your z plus to be the positive integers to be z plus instead of simply n. We're going to denote n to be your natural numbers. So on Z, there are two basic binary operations. You are familiar with this: addition and multiplication. These are not the notations. It should satisfy some basic properties for every property for Z. What are the basic properties? You are familiar with associativity, commutativity. Commutativity property for addition, ano yung ibig sabihin nun? Can actually rewrite it as follows. If you have A plus B, then you can commute. You'll have B plus A. For multiplication, garin din. If you have A times B, then it should be B times A. The other property is your associativity. So that is, if you have A plus B grouped together plus C, then you can add up A plus group together A, B plus C first. Similarly, sa multiplication, you can group together the first two and then multiply on the third value here. Remember that these are your integers. Okay, so these are the properties. The distributivity property, multiplication over addition, you're familiar with this one. You can distribute A times B and you can have your A times C. So these are the basic things that you need to know. So this one, I hope you are familiar with this already. We have what we call your identity elements. Identity for addition and these two operations, plus and multiplication. So the identity element for the plus is 0, and the identity element for multiplication here is 1. That is for all elements of the integers, A element of Z. So set C allows additive inverses for its element such that there exists integer Z, you will have negative A. But you have to be very careful that for set Z, so multiplication, it's not necessarily true. Only the integer 1 has a multiplicative inverse. A inverse of 1 is actually equal to 1. All the rest don't have a multiplicative inverse. Why? For example, 4. 4, what is supposed to be the inverse of 4? Anyone? Hello? Can you hear me? 1/4. But it's not an element of your integer. Correct? That's why. Yes, that's the reason why the integer 1 is the only integer which has a multiplicative inverse. All the rest, wala na. Okay. So from the operations of addition and multiplication, one can define two other operations on Z. That is your subtraction and your division. So we say that subtraction is a binary operation on Z, defined for any two integers in Z. So subtraction and division are defined as follows. You will have A minus B is defined as A plus, okay, the negative of B. But we know that the negative of B and added with A would also be an element of your integer. But if you have A over B, if this is defined by the integer C, if and only if A is equal to B times C. Otherwise, that is not fine. Next natin. Go to the next one. So what are the piano actions? First one, anong kailangan natin? We need a set N together with a successor function such that you have the first one here. The first action says 0 is an element of N. Also, if x is an element of n, then s of x is an element of n. There is no x element of n with s of x equal to 0, successor of x equal to 0. And then, if the successor of x is equal to the successor of y, then x is equal to y. If S is a subset of n containing 0, and if the successor of n, this is an notation for successor, element of S, whenever n is element of S, then S equal to n. So, we take a note with the definition of a successor function. It says that it sends a natural number to the next one. So, for example, successor of n is the function equal to n plus 1. So, successor ng 1 will be 1 man nandito, so 1 plus 1, so successor is 2. Successor ng 2 will be substituted to 2 plus 1, so you have 3. So remember that we are on integers, but this time because we have 0 is an element of n, ibig sabihin, you start with 0 because there is no x element of n with successor of x equal to 0. So, hindi kasali yung mga negative integers. So, again, let us simplify yung pina-action. You have a natural number set or set n, set together with the successor function. The successor function is given by s of n equals 1 plus n. 0 is an element of n. If x is an element of n, then s of x element of n. Anong ibig sabihin ng mga yan? These are actually the elementary notion of sets. Also, it belongs to basic properties of your natural numbers. So, yung pina-axioms are simply the basic properties of your natural numbers. Now, let us take that one as a remark. Yung n1, which is 0 is an element of n, simply says that 0 should be a natural number. Diba kanina, if you remember, merong mga ibang books na they do not include 0 to be an element of the natural number. But because of this axiom, 0 should be a natural number. Here, 0 is an element of n. The second axiom states that if x is an element of n, then s of x is an element of n. Ibig sabihin niya, s is a map from n to n. That is, each element of the natural number gets mapped to another element of n. It's a function mapping. Huh? It says also on number 3, there is no x element of n with s of x equal to 0. It says that 0 is the first natural number. I mean to say, as I've said earlier, negative 1 is not an element of n. So you start with 0. Ang n4, ang ibig sabihin nun, if s of x equal to s of y, then x equal to y. So the map s n to n is actually injective. Ano na uli yung injective? By definition, a map f from A to B is injective, or we usually make use of the word one-to-one if f of A is equal to f of A prime, for A prime element of A implies that A equals A prime. So in other words, if different elements get a map to a different image. Ang n5, if S is a subset of n containing 0, and if S of n is an element of S, whenever n is an element of S, then S equal to n. That is simply what we call your principle of induction. And in principle of induction, we will just take a look at some examples here, but I'll give you a thorough discussion on the principle of mathematical induction. As I've said, dapat nung master nyo yan, mga BS Math kayo, mga principle of mathematical induction. Axiom N5 is called the principle of induction. You assume that you want to prove a statement, P sub n, then if you, for example, you want to prove that n squared plus n is even for all n. You let S denote the set of natural numbers is the element of n, for which P sub n is true. Now, you have to show that it should be true at p of 0. Meaning to say for if pag n, start ka sa n, then 0 is the first element there. So if it is true for that one, then it should also be true for the next one. So that's the principle of induction. So your Pino axioms characterize the natural numbers. You put 1 equals the successor of 0, 2 is the successor of 1, 3 is the successor of 2, 4 is the successor of 3. In particular, the set of natural numbers are as follows. So let's take the second remark here. Ito yung sabi ko kanina, some mathematicians prefer not to regard 0 as a natural number and define that. Yun yung first na ginamit natin dun sa, but as I explained earlier, this time, we would like to have this one. 0 is an element of your natural numbers. So because the construction of the integers from the naturals would be complicated if we don't have a 0. Now we go to the fundamental properties of the set of integers. These properties provide the foundations for proving results in number theory. So as usual, we denote the sum of the product by this one, a plus b and a times b respectively. The first property is what you call your closure property. Closure property, it means to say that if you add and multiply two integers, then the result should be an integer. Ibig sabihin ng closure, na? Closed siya under multiplication and addition. Commutative laws, we discussed that one earlier. So we can, a plus b is the same as your b plus a, and a times b is the same as your b times a for all integers. Associativity was also discussed earlier. Ito sa set of integers, kanina sa natural numbers, no? Distributive law, you are familiar with this one. A plus b, the quantity times c is equal to a times c plus b times c. Again, as a recap, you have your identity elements. A plus 0 equals a, and a times 1 is equal to a for all integers. You have your additive inverse, discussed earlier. That is, for every integer a, there is an integer solution x to the equation a plus x equal to 0. There is an additive inverse. The cancellation law, that is, if you have a times c is equal to b times c, as long as c here is not equal to 0. You will have a is now equal to b, because you can divide both sides by c. Otherwise, if c is not equal to 0, then a is not necessarily equal to b. So we can use these axioms and the usual properties of equality to establish additional properties of integers. Also, what we call your closure for positive integers. So a plus b and a times b are positive integers whenever a and b are positive integers. And you have your trichotomy law for integers. It says that for every integer a, exactly one of the statements a greater than 0. So ito lang ang pwede, no? Either a is greater than 0, a equal to 0, and a is less than 0 is true. Hindi pwede na both a greater than tapos equal sa 0. It's either positive siya, equal siya sa 0, or it's a negative value. That's what it's meant. What are the basic properties of ordering of integers? Suppose we have the following example. A, B, and C are integers with A, B, and C greater than 0. Diba sabi ko kanina, may mga values or may mga things that you have to prove. Parang obvious na, pero you have to consider this. You have to show that AC is less than BC. How do you do that? You are given A is less than B, and C is greater than 0. So how are we going to show that AC is less than BC? So we make use of a very simple proof. So first now, by definition, we are given dito, A less than B. Suppose that A be with A. Ito, ang given. And C greater than 0. So from A less than B, we can actually rewrite it as 0 is less than B minus A. What did we do? We subtracted both sides with A. A minus A, and you have B minus A. You can do that, diba? Because of the closure property. So whatever, it's still an element of that one, and there is what we call your subtraction. So because the self-positive integer is closed under multiplication, what do we do again from here? We can multiply C. We know that C is greater than 0. Given minus C. So when C is greater than 0, then you will have, when you multiply it by C, you still have the same inequality sign there. And from there, you can operate CB minus CA, that is C times the quantity B minus A, that's C times B minus A, will give you 0 is less than CB minus CA. Again, ang gagawin natin sunod. We again add CA on this side and CA on this side. So you'll have CA is less than 0. But we know na commutative ang multiplication. It follows na kaning CA is the same as your AC, so AC is less than. And you have proved that AC is less than BC. So very simple yung ano, no? Pero yung mga steps niya are basically from the properties that we had studied earlier. So when you are asked to prove that AC is less than BC and you are given this, then you should be able to identify kung ano yung ginamit ninyo ng mga properties. So the set of integers is said to be an ordered set because it has a subset that is closed under addition and multiplication. And because we had discussed earlier, the trichotomy law holds for every integer. So ano yung trichotomy earlier? You remember? Ayan natin, pag-malalan nyo. Ito yung trichotomy natin. Ayan, no? For every integer A, exactly one of the statements, either A greater than 0, equal to 0, and A less than 0 is true. Are you still with me? Hello?
Yes, ma'am.
Yes, ma'am.
So, dito tayo sa well-ordering property. It's a very important principle. The well-ordering property. Kahit pagdating ninyo sa higher math, you will need this. Na? Every non-empty set of positive integers has a least element. Yun ang ibig sabihin ng well-ordering property. But remember that it says non-empty set of positive integers. So positive has a least element. So hindi kasali yung mga negative integers. Why? So the principle of mathematical induction is a consequence of the set of the actions that we had earlier. Sometimes the principle of mathematical induction is taken as an action replacing actually your well-ordering property. That's why later on we're going to prove more examples on making use of the principle of your mathematical induction. Again, what is your well-ordering principle? A least element exists in any non-empty set of positive integers. So pareho lang yun sa mistake kanina. But sometimes it's stated as a least element exists in any non-empty set. So it should be a non-empty set and it should be a set of positive integers. So set of positive integers is well ordered. Because of this principle, ang set of positive integers is well ordered. On the other hand, ang set of all integers, kasi kasali yung 0 at saka ang negative, is not well-ordered. Ang well-ordered lang are set of positive integers. The reason is this. There are sets of integers that do not have a smallest element pagdating sa negative. Because if you start with negative 1, may pa mas maliit sa negative 1 up to infinity there. Pero, sa set of positive, we know that there will always be a least element set of positive integers. So for examples, for more examples on the well-ordering principle, I gave you some video clips to watch. I hope napanood nyo na to. There are 3 there. So you can take a look at this. Kung hindi pa, then please try to study and take a look at the examples on the well-ordering principle. What is the pigeonhole principle? The pigeonhole principle says that if S objects are placed in K boxes for S greater than K, then at least one box contains more than one object. Imagine niyo, you have, let's see, I don't have my pen right now. Kapanyari ito. Ito na ready. Sige na lang. So, for example, you have there K boxes. Yung K boxes ninyo, or pigeonholes in that case, no, is less than the number of objects. So, dapat may isang box na nag-contain ng more than one object. And the proof is actually, again, as I've said, medyo, ano siya, no? Make use of the idea that suppose none of the boxes contains more than one object. Suppose dito, kasi ang conclusion, at least one box contains more than one object. Suppose, wala. At least one daw nag-contain. So let's just consider that none of the boxes contains more than one object. What happens? Then, kay K man itong inyuhang, kay boxes man to siya, ang objects ninyo, sakto-sakto naman. So there are at most K objects. And nasulod naman siya tanan. And because of this, natay contradiction. Kaya nga naman, to start with, kabalutan na ang S objects is greater than K. So, hindi pa nasabtan eh. Dalawa na to. There is a different way of stating this one actually. Sometimes it's stated as follows. If K is an element of Z plus, we can say positive, na? Positive integers. So, wala labot ang 0. Starting with positive. And K plus 1 or more objects are placed into K boxes. So, K element of Z plus, kanalang imuhang boxes. Pero na kay K plus 1. Then, there is at least one box containing 2 or more of the objects. So, yun ang ibig sabihin ng pigeonhole principle. We prove the pigeonhole principle using proof by contraposition. That's what we did earlier. Suppose that none of the K boxes contains more than one object. Suppose, kaya mo siya at least one. Then, ano yung conclusion? Then, there is at least one box containing 2 or more objects. Suppose, on the contrary, na dili ni siya tinuod. Suppose that none of the K boxes contains more than one object. What happens? Then the total number of objects would be at most K. Meaning to say, contradiction na siya. Because, kabaluman ta na K plus 1 ang given na objects. Example tayo para mas masabtan. Show that if there are 30 students in a class, then at least 2 have last names that begin with the same letter. How are we going to show this? Anyone? Na may idea? Nanawagta. Asera, Krisha. Krishaan. Can you hear me? Hello? Am I still with you? Oh, Krisha. Krishaan. Can you hear me? Give me an example. This one. What is the reason why? How are you going to make use of your pigeonhole principle here? Sino pa bang tawagin natin dito? Mantiza, Kent.
Pag-ulam nila.
Ha?
Kuan mo.
Isa ni. Identify yourself first. Di ko kita sa inyo. So please just identify.
Suppose ma'am na 2 is greater than or equal to 30.
Kinsa ni palihog. Identify yourself please.
Able ko ma'am, guro.
Okay, guro. So what is your solution for this one? How are we going to show that there are 30? Huh? Yes? Choppy ba ako sa inyo? Choppy kayo kasi eh.
No, ma'am.
Hindi, o sige, sige. Ang sa maning solution ani karon?
By contraposition, ma'am.
That is, there are supposed to be, yes, that's correct. There are, kasi ang sabi niya, there are 30 students in the class. At least 2 have last names that begin with the same letter. Show na there are students na pag na daw 30, at least 2 have last names with the same letter. Pila man lang taka letters, ang boxes na to karon ay kato mga letters niya, 26 raman ang letters, di ba? 30 man ang mga students. So, naagyod siya isa diri, at least 1, nga kapareho sila og last name. So, kay 26 letters, lahi-lahi para sa inyo ha. Si Abdul, Asera, naaman, 32 man mo tanan. So, kaning si pila man ka letters ang alphabet, diba? 26 lang. So, if you take a look, si Abdul, Asera, Adolfo, ug Ambray, Antatico, si Ato, nabilong sila sa isa ka box. Okay? 32 man matanan. Si Bahinting, isa raman siya. So, isa ra siya sa letter B. And then, we have Kampong, Candano, Castro, Katian. Nabilong siya sa letter C and down the line. Okay? If there are 30 students in a class, then at least 2 have last names that begin with the same letter. Okay? Hindi siya pwede mo 1-to-1. Show that if there are 40 faculty members in the math department, then at least 2 have the same birth month. Saan kayo solution, Ani? Anyone? Lopez, Juniel. Niya. Di wala si Juniel or dili ka tungo si Juniel sa ako. Fernandez, Daniel. Nakuha ba ang concept sa Pigeonhole Principle? Wala pa?
Wala pa nga yun ma'am. Pwede ba naman?
Pila man ka months? 12 months laman
12
na?
months ma'am.
So 12. Muna inyo hang pigeonhole. Katong 12. Yung 40 ba kabuo? So, mean to say, na dito'y pareho ang birth month. So, sa pigeonhole principle with this time K equals 12. Sige. K equals 12. There is what you call your generalized pigeonhole principle. Pag generalized, kaya kung mag-discuss anino, usually this is discussed in your ang tawag nitong topic. Sa Math 104 man ito, discrete math. Discrete mathematics. So, I don't know kung may naamoy discrete na mathematics. Usually, yung generalized pigeonhole principle and the pigeonhole principle are discussed in discrete mathematics. Pero nabilong gihapon siya sa number theory. So if n objects are placed into k boxes, then there is at least one box containing at least. This is the ceiling integer. You're familiar with this notation? Ceiling integer. That is the greatest integer function. Now we go to the principle of your mathematical induction. So we say we actually have the two principles. The first principle, the mathematical induction, says that if you have a set of positive integers that has the property that it contains the integer k, then it also contains k plus 1. And if this set contains 1, then it must be the set of all positive integers. So more generally, what do we have here? The positive integers, a property concerning the positive integers that is true for n equal to 1, then it should be true also for n plus 1. So, if it is true for n equal to 1, true po siya sa value which is the next value. Let's just try to prove your principle making use of the well-ordering principle. Let's see. You have S be the set of positive integers containing integer 1 and the integer k plus 1 whenever it contains k. We usually do not prove this, no? Pero at least para may idea sa pag-prove sa principle of mathematical induction. So we have assumed that S is not the set of positive integers. It's not the set. So as a result, there are some integers that are not contained in S. Kaya man siya, not all man. So because of that, those integers must have at least element. A least element by the principle of, by well-ordering principle. So that we have alpha is not equal to 1 since 1 is an element of S. But we know that we can have alpha minus 1 is an element of S because we can actually subtract 1 from there. So using the property S, alpha is an element of S. Therefore, S must contain all positive integers. Ano ba ginagamit natin sa subject 104? I think it's the second principle of mathematical induction. This is what you usually make use of. I will not deal with the proof anymore. Just try to take a look at, di na ko mag-deal sa proof ha. Example na lang taan. Okay, let's take a look at this. Use mathematical induction to show that for all n elements of n, the summation of j is equal to n times the quantity n plus 1 over 2. Anong ibig sabihin yan? There are three steps in trying to make use of your mathematical induction. First, you identify the quantity that you're going to prove. So say P sub n or P of n. So ito man yung prove natin. The summation of j equal to 1 to n is equal to n plus 1 over 2 for all n element of your natural number. We start with that. Start with summation of j equals 1 when j is equal to 1. 1 times 2 over 2. Substitute. Equal to 1. So it is true for n equal to 1. Ang gagawin natin, you have to identify. So ito man prove natin. Ito yung P sub n natin. Then after that, identifying the one that you're going to prove, you verify if it is true for initial values. So you verify for n equal to 1. So when n equal to 1, you will have summation of j, which is 1, equals, what is that? 1, when n equal to 1, 1 and 1 there. So you have 2 over 2. So cancel out. So 1 is equal to 1. Suppose that the formula holds for n. Mean to say, you assume that the formula is true for n equals k, or in this case for n ang ginamit niya. Then you will have summation of j equal to 1 to n is equal to n over n plus 1 over 2. What is our aim? We'd like to show that it will also be true for the next value. Diba? That is, we show that it will also be true for anong next value after n plus 1. So this is what we'd like to show. Ang summation of j equal to 1 to n plus 1 will give you kaning n dire, you add with 1. Kaning n plus 1, you add with 1. No? Maging n plus 1 plus 2. So you will have n plus 1 plus 1 will give you n plus 2 over 2. So this is what you want to show for the principle of mathematical induction. So indeed, what do we have? Kani, taman diri, is actually equal to summation of j. Kay true man siya taman diri sa j. Assume man ta nga true siya. So summation of j plus ang next number niya, na i-add ninyo kay taman diri, taman sa n, correct man siya j. The next niya is plus n plus 1 kung tama na siya sa n. Which is the same as n, kanina nang taman sa j, di ba? n plus 1 over 2 plus this one, n plus 1, which is equal to, you can take the LCD. LCD is 2. Then you have n plus 1 plus times n plus 2. Right. So this one actually follows. Napay steps diha, no? But kaya naman na ninyo. Let us have another one. Use mathematical induction to prove that n factorial is less than or equal to n raised to the n for all positive integers n. Say you have verify for initial values of n. And 1 factorial is equal to 1 less than or equal to 1 to the 1, which is 1. Okay siya. So, by inductive step, we have suppose na true siya up to n. We'd like to know if it is also true pag sunod after n, that's n plus 1. So, we prove that n plus 1 factorial, di ba, plus that, is less than or equal to n plus 1 raised to the n plus 1. Kani n plus 1. That's what you want to prove. What do we know? N plus 1 factorial is equal to kani n plus 1 times n factorial. You are familiar with this? Ano ang n factorial notation ninyo? N factorial is 1 times 2 times 3 up to n. So, kung ikag n plus 1 factorial, that would be n factorial times n plus 1. But this is less than or equal to n plus 1 times n to the n. Why? Because n factorial is less than or equal to n. Kani, mas gamay man siya sa less than or equal siya sa n to the n. So, i-replace man ninyo ang n factorial by n to the n. So, we mean to say this is less than n plus 1, n plus 1n is equal to n plus 1. So, that completes you. So, again, for more examples, I have a video clip for this one. You can refer to this. Then I'll give you more examples later on. These are the exercises you are asked to prove using mathematical induction. The assignment will be due on next meeting, before next meeting. So, mga Thursday. You have to solve number 1, number 4, 1 and 4. I'll give you more examples later on. Assignments later on. So 1 and 4, 1. So references, we have the following. Lecture notes, all lecture notes.